If the position vector A of a point with coordinates 5, n has a magnitude of 13, what is the value of n? Okay, let us begin. Let's try to understand the problem graphically. So here we have a two-dimensional coordinate system. We're going to consider a point, let's call it the point A having the coordinates 5, n. It's given here that if we join point O and A with the help of a directed line segment going from O to A, that's going to give us the position vector of point A. It's given here that OA vector is represented by A vector, and also the magnitude of OA is 13 units. So with this information, we need to find out the value of the n, that means the y coordinate of point A. Okay, now from this figure, it's clear that here we have A vector, which is the position vector of point A. Now this can be expressed in terms of the unit vectors I cap and j cap. All we have to do is drop a perpendicular from the point A on the x-axis. Let's say it meets at the M, and then drop another perpendicular from the same point A on the y-axis, meeting it at N. Now we know that I cap is the unit vector along x-axis and j cap is the unit vector along y-axis. Now that means A vector is going to be the x component of A vector, which is 5 units. And this is a scalar value. In order to express it as a vector, we're going to multiply it with I cap, indicating that it's along the y-axis. So phi I cap is the component of A vector along the x-axis. This will get added to the y component of A, so that's n, but n is a scalar. We have to multiply with j cap, indicating that it's along y-axis. So we have expressed the vector A in terms of I cap and j cap. Also it's given here that the magnitude of vector A that's equals to 13. However, we know for a fact that the vector A can be expressed, the magnitude of vector A can be also expressed as take the square root. Underneath the square root, we need to take the square of sums. That means we'll take the component of I cap, which is 5, square it and add it to the square of the component of j cap. So that's n squared. So using this value, we're going to get 13 equals to the square root of 25 plus n squared. Squaring both sides, it's going to give us 169 equals to 25 plus n squared. So solving for n squared, we're going to get n squared equals to 144, which implies that n value is going to be plus or minus 12. So there are two values of n that are possible. So A could be having the coordinates 5, 12, or it could have another coordinate, let's call it B, with coordinates value 5, -12.